rather is an established fact that males are more, how will I put it? Maybe males contain more adrenaline, such that they will be, or less adrenaline, such that they are able to withstand heavier or bigger animals. Because I know that I'm a practitioner on the field, and I know women who have cattle. Cattle are much more bigger than turkeys. How will you reconcile this?
Thank you. It's not established fact. That's why I say maybe due to their sizes. So I am assuming. Thank you.
Thank you very much. Have we done characterization of the turkey itself in Ghana? Characterization of the turkey itself. Has it been done?
I've seen Yodu and at Amstead. They have done it across, I think, 4 districts. Ashanti region, Bono Hafo.
Did you utilize those information in your work?
Yes, I utilize them.
Okay, let's give it up. Okay, so Lady Hanson. Characterization of KAKA's attributes. Okay, 10 minutes.
Good evening, ladies and gentlemen. All protocols duly observed. My name is Catherine Baba Hansen, and under the supervision of Reverend Professor Richard Osiamponsa, I'm presenting on the topic Characterization of Carcass Attributes of Croiler, Noila, Hubbard, and Local Chickens. So my presentation will be in this format where I'll start from the introduction through to the recommendations. Poultry production in Ghana plays a crucial role in the nutrition, income generation, and sociocultural benefits. And in Ghana, setting up intensive production system is becoming quite a challenge due to the high capital investment required to maintain ideal conditions, especially for the exotic breeds. And the increasing population has led to an increase in demand for chicken meat and eggs. This has led to a heavy reliance on imports. And these and many reasons are why researchers under the International Livestock Research Institute developed the Tropical Genetic Solution Project that introduced hybrid breeds that have been selectively bred to thrive in our tropical regions. Examples of these breeds are Croiler, Noila, Hubbard, and Sasso chickens. So even though there are information on the growth rate, feed conversion efficiency, and their egg production rate, there isn't much data on the consumer preference in terms of meat quality and taste, as well as carcass characteristics of these breeds, especially when compared to the highly preferred local chickens. And therefore, I sought to assess the carcass weight and dressing percentages of these experimental birds, assess their breast meat, drumstick, thigh, and wing weight, and evaluate the aroma, taste, tenderness, texture, and overall acceptability with the help of a taste panel exam. So this research was conducted at the Livestock and Poultry Research Center located in the Greater Accra region of Ghana. It has an annual rainfall amount approximately 700 milliliters to 1,000 milliliters, and the vegetation type is primarily tropical savanna. The chickens were reared in intensive system and commercial feed was provided for all the breeds. And this experiment lasted between the months of October and December 2024. 10 chickens were randomly sampled, 2 from each breed, and slaughtered at the age of 14 weeks. 2 cooking procedures were used, that is the grilling method and the boiling method. And 12 panelists were conveniently sampled to help with the taste panel exam using a 5-point hedonic scale. So these are pictures that shows my research experience from day one of weighing the live, recording the live weight, and then to the taste panel exam. One-way analysis of variance procedure from GenStar 12 edition was used for the quantitative analysis. And Kruskal-Wallis one-way statistical test was used for the non-parametric data analysis, which is the taste panel exam. Mann-Whitney yield test was also used for the pairwise comparisons between the local chickens and each of the tropically adapted improved breeds. So the table shows the means and the standard errors of the quantitative parameters I measured, which is the carcass weight, dressing percentages, breast meat weight, thigh weight, drumstick weight, and wing weight. And it was noticed that the Croiler and Noila breeds had the highest yields, with the local chickens having the lowest yields. Under the sensory test done by boiling method, there was no significant differences observed. However, in the grilling method, the local chickens were slightly preferred. So the carcass weight results showed high significant differences among the 5 breeds, and the dressing percentage results yielded no statistical differences. These findings are consistent with earlier studies by Afolayan and others in 2019, which showed that the improved breeds performed better in carcass yields as compared to the local chickens. Abeba and others in 2022 also stated that local chickens had slower growth rates, low feed efficiency, and that genetically predisposed towards adaptability rather than productivity. Ajayi and others in 2022 also stated that the Noila and the Croiler birds have been bred for higher growth rates and better carcass conformation, ultimately leading to higher wing weights. The sensory test done under boiling method the differences across the breeds were minimal, suggesting that the boiling reduces variation between taste and texture. And the sensory test done under grilling method, local chickens were slightly more preferred due to their firmer texture and stronger flavor, and these are attributes that are highly valued in the Ghanaian diet. So in conclusion, the improved breeds showed superior carcass weight. There were no statistical differences in the dressing percentages, and the local chickens underperformed quantitatively, but then retained their cultural value, especially under the grilling method, due to their texture and flavor. So based on these findings, I recommend the following. Promote dual-purpose breeds like the Croiler and Noila to improve raw meat production and household nutrition. Standardize slaughter age and carcass processing practices to enhance meat quality and reduce post-harvest losses. Establish decentralized meat processing and cold chain facilities in rural poultry, and also develop consumer education and branding strategies to help promote the grilled local chicken as a cultural delicacy. Thank you.
Thank you very much, Lady Hansen. So I will invite some 3 questions. Yes.
Thank you for the wonderful presentation. Please, I would like to find out, how did you do the carcass analysis? How did you kill the bears?
How did I kill
the carcass data? How did you do it?
Okay, so I recorded the live weights on the day of the slaughter, and then after slaughtering and evisceration, I recorded their carcass weights.
Okay, I want to find out, after slaughtering, did you allow the animals all to bleed at the same time, or you kill, then you start with the weight?
Okay. I wasn't the only one that did the work. I had help from some farmers at the Leprek Research Center to help with the killing, slaughtering of the birds, and then the feathering and everything. So as they were doing it, I was recording their carcass weight.
The reason why I'm asking, when you kill the animal and you don't allow it to bleed, that one too can influence the carcass weight. So that's why I'm asking.
Okay, thank you. I'm here. You have made two remarks. And first of all, you indicated that in terms of likening, the panel liked the local chicken, right?
Yes, under
Good.
the grilling method.
Yes. Now, your recommendation, you are recommending that we should grow those that they did not like. How do you marry these two?
It wasn't that they didn't like the improved breeds, but then the local chickens were slightly more preferred.
Yes, because they are slightly more preferred. Why can't you just push that one for them to be wholly preferred, rather than advocating for growing others that are not preferred by, it's not about yield. You understand? It's about consumer acceptability of the product. And what drives the acceptability of the product is from the consumer. And the consumer tells you that, I like this. Are we together? So the recommendation that we should encourage the growth or the rearing of those that they are not preferred is ambiguous. Are we together? Yeah. Thank you, Chair.
Okay, thank you very much. Please, I would like to seek this clarification. Were the animals raised by you or you purchased them? I might have messed up on that during your presentation. Did you raise them from day one till slaughter? And if they were raised from day one till slaughter, were they on the same feed or they were fed different diets? Because I think the diet could have influence on the final product.
They were raised on the same feed. So this is my final project work, and we were 3 students working on those birds. So 2 of the students were working on the morphological characterization. And then when they were done, I worked on the carcass attribute. So the birds were bought as day-old chicks, and then they were provided the same feed so that there won't be any variations when it comes to feed.
Okay, so the local ones too, were they able to catch up with the exotic ones, comparing the growth rate and then the final body weight? Because the local ones, I know it's going to take time before they match up with the exotic ones. So how was it like?
Okay, so the Hubbard breeds are broilers. Okay, so they were supposed to be normally slaughtered at around 8 to 10 weeks, but because within 8 to 10 weeks the local chickens wouldn't have been matured enough, as I waited to 14 weeks, and it's part of my recommendations that we should standardize slaughter age for all the birds, for all chickens, to prevent loss of quality and then loss of yield.
So much for the understanding, for want of time. All right, so let's give it up to Our Lady, and then next, do we have effect of orange flesh potato vine? Is that presenter around? I think no. How about intestinal morphological hematology and serum blood parameters on Japanese quails? I think this should be from Dr. Aidan. I saw him just pretty soon. Who is doing the presentation? So do we have Derek Amwa here? Derek Amwa, you are calling him? Okay. All right. Okay. So we're waiting for that person to do the presentation. But in the meantime, I think the word kill is forbidden. So let us be mindful of how we use that word in our write-up. We're using even slaughtering, but that word, even they don't even like it now. They want sacrifice. So these are issues that we have to deal with. Yes. 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 Have you loaded your presentation? We know, but have you loaded it? So go ahead. Let the lady assist you too.
Hello. Um, okay. Um, Good evening, senior members and fellow participants. My name is Amwako Derek, and I'm standing in place to do a presentation for a group work that we did during the undergraduate degree, which was being supervised by Dr. Frank Aidan. I'm here to present on the effects of dietary rice bran inclusion at varying levels on growth performance, carcass rate, and economic analysis of Japanese quails. The outline of my presentation is as follows. Poultry production is one of the largest contributors of meat as far as the global demand is being concerned, due to the fast growth and its low initial feed conversion ratio. Also, quail production as one of the poultry production has also become a lucrative venture due to the low initial investment and the nutritional benefit of eggs it also provides. Japanese quails are one of the hardy birds that often thrives in small cages and are also inexpensive to keep as compared to other poultry birds such as chicken. However, we know that in the industry, feed cost has also been a major challenge, and which has always accounted for about 70% of the total cost of production. And so this has also sparked considerable interest among various researchers to come up with other alternate feed ingredients that can help to mitigate the challenge of feed cost. The use of these alternate feed ingredients such as rice bran, corn cobs, and other byproducts can also help to reduce the cost of production. And so these ingredients such as rice bran have great potentials to be used as animal feed and also helps in the development of the gastrointestinal tract of poultry due to the presence of fiber as reported by J.M. Mishra in 2021. Rice bran, a byproduct of the rice milling industry, contains a substantial amount of protein, also vitamins, minerals, and also can serve as a source of energy in the diet of poultry birds. And so previous studies suggest that the inclusion of rice bran between 10 to 20% in broiler diets, depending on the geographical origin of the rice and the level of the supplemental enzymes, does not negatively affect growth performance. And so the study hypothesized that the inclusion of rice bran up to 30% in quail diets would not negatively affect growth performance and carcass rates, as well as also helps to reduce the cost of production. So the main objective was to examine the effect of dietary rice bran inclusion at varying levels on growth performance, carcass rates, and economic analysis of Japanese quails. The specific objectives of the study were to also identify the optimal inclusion of the levels of rice bran in quail's diet that can maximize growth performance. Also to assess the impact of varying levels of rice bran levels on the growth performance of Japanese quails. Also to further examine the influence of rice bran inclusion on the carcass traits such as the thigh muscle yield, the carcass weight, and the internal organs. And lastly, to also evaluate the economic feasibility of incorporating rice bran into the diets of Japanese quails by analyzing the feed cost and the cost of feed per gain. The materials and method. The study was conducted at the poultry section of the Department of Animal Science. The experiment lasted for over 7 weeks. The bears were randomly assigned to one of the 4 dietary treatments using a completely randomized design with 4 treatments replicated 6 times. And the treatment diets were formulated to differ in the inclusion levels of rice bran, that's from 0 to 30%. Feed ingredients were sourced locally from GSAP in the market, then being mixed in a 2-ton vertical feed mixer at the Department of Animal Science. Diets were formulated in 2 phases, for the starter to the grower phase and from the grower to the finisher phase. And diets were formulated to contain the same energy and also the same protein. 242 weeks old Japanese quails were purchased from GSAP, with M bears being placed in each of the 24 cages as being shown on the slides. And the bears were also provided with water and feed, albutum, as husbandry practices of bears is being concerned. The data that were being collected include the growth performance. Body weight and feed intake were collected or measured on a weekly basis and used to calculate for the final body weight, the body weight gain, and the total feed intake. Mortality was also monitored on a daily basis to adjust for the feed conversion ratio. At the end of the experiment, 2 bears with body weight similar to the cage weights were selected from each replicate to be used for the carcass parameters. And as well as the economic analysis was also being determined by knowing the individual feed ingredient cost and the cost of feed per gain as being described by research conducted by Frimpong and others in 2019. Statistical analysis, all data obtained were subjected to ANOVA using the Gribbig-Sachs procedure and the version 9.48, the SARS Institute 2023. Treatment means were being separated at a significant level of 0.05. So this is the results and the discussion. So table 1 shows the calculated proximate composition of the rice bran. From the table, we could see that the crude protein of the rice bran as compared to that of maize is higher. And we see the metabolizable energy also falling within the range of 2,870.66 kilocal per joules. And this proximate calculated also aligns with what the overall metabolizable energy falls within the range as a study was being conducted by Sprader and others in 2021. However, the proximate that we had disagree with what Mulan and Manzor conducted a research in 2023. Table 2 shows the ingredient composition of the experimental diet for the starter phases. The diets were formulated to contain the increasing levels of rice bran from 0, 10, 20 to 30%. Table 3 also shows the calculated nutrient composition of the experimental diet for the starter phase. Here we make sure that the diets that we formulated were isocaloric and isoenergetic to the extent that diets have the same protein and the same energy content. Table 4 also contains the same dietary composition of the experimental diets for bears that were being fed from the grower to the finisher phases with the same treatments as rice bran, increasing from 0 to 30%. And the table 5 also shows the same trend for the calculated nutrient composition for the diets used during the grower to the finisher phase, with the diets having the same energy and the protein content. Table 6 shows the effects of the increasing level of rice bran on the growth performance. From the results we obtained, we found out that the inclusion level of rice bran had no significant effect on the final body weight, the body weight gain. However, the total feed intake and the feed conversion ratio was being affected. Table 7 also shows the effect of the increasing levels of rice bran supplementation on the carcass rate of quails. From the table, we observed that no significant differences were being observed in the carcass parameters that are being highlighted in the table. Table 8 also shows the economic analysis of the experimental diet, that's from the starter to the finisher phase. And we found out from the results that birds that were being fed 30% or an increasing level of rice bran had a lower feed cost as compared to the other treatments. And this also aligns with a research that was being conducted by Abrana and others in 2014, which also suggested when 20 to 40% rice bran was also used in similar tests or experiments. And so our study or research conclude and recommend that dietary rice bran inclusion up to 30% in Japanese quail diet did not negatively or adversely affect the growth performance nor the carcass rate, but however reduced feed cost, demonstrating rice bran as a potential cost-effective feed ingredient in formulating the diets of Japanese quails or poultry as a whole. And so we recommend that further research should consider the sexing of the quails to examine the effects of dietary rice bran inclusion. Thank you very much.
All right. Thank you. We shall take some 3 questions. Okay.
Thank you, Chair. Let's just look at your table 20, the economics of analysis of using rice bran, because you are encouraging us to use rice bran up to 30% in the diet.
Yes, please. I've moved that.
You know.
Okay, so you said slide 20.
Yes, slide 20.
Okay, okay.
If you look at that table, you realize that feed cost reduces, okay, that you mentioned. However, if you look at feed cost per gain, which is very, very crucial, it has been increasing. So as your feed cost is going low, your product becomes expensive. Have you seen that? Because at 20%, it's 23.2. And at 0%, it's 21.2, approximately. Are we together?
Yes, please.
So I don't think it is prudent to use that as a justification for the use of the material up to 30%. And then table 1, you mentioned calculated proximate analysis. I don't understand what it means. This one. Okay, you calculated the proximate analysis. Come again.
Yeah, so this is the result for the proximate. We did the proximates and based on...
So it is not calculated, it is analyzed. Okay. Is the proximate analysis component of the, what do you call it, the rice bran? Okay. Yeah. And then my last question is, the addition of the rice bran, which method of inclusion have you used?
Okay. The method as in the quantity that we used, or?
You may not understand. The rice bran. Okay. Have you substituted rice bran with a particular ingredient in the diet? Or you substituted part of the diet for rice bran? Or you did incorporation? These are the 3.
Okay, so what the study was about is we incorporated, so we just incorporated the rice bran.
Yeah, so you treated it as an ingredient.
Yes, please.
Okay, thank you.
Okay. Mr. Derek, I think that was a good presentation. Actually, I'm recently working on a similar project. That's the quills. But I'm running into some difficulties. So I don't know. What was the mortality rate in your experiment? If there was any.
Okay. So during the study, I already indicated that the mortality was monitored on daily basis and used to adjust for the feed conversion ratio. But we found out from the study that the mortality was not treatment specific, in a sense that the few deaths that we recorded were randomly distributed among the treatments that we use. And so there were few deaths. Okay, we recorded, but it was not, I think, relevant. Okay, we recorded about 5 bears out of 240 bears. Thank you very much.
All right, if there are no further questions, I think we would have to, yes. Thank you. Let me find out if these presenters are here. Do we have Conlan? Is he here? No? Okay. Then the one on quarantine and public health activities at PAGA. I doubt if the presenter is here. Nyayali? Not here. Okay, so we have proximate and mineral analysis of some insect larvae. And then this one is Muhammad. Muhammad? Okay. Next, we have the response of broiler bears to diet containing greater levels of rice, milling waste, and phytates. And that one is Ashon. You are here. Okay, but I don't know if you have your things. Okay, please.
Good evening, Mr. Ashon Evangeline Aboli Dromo, and I'm here to present on the topic response of broilers to diets containing greater levels of rice milling waste and phytates. The major challenge in the poultry industry is the cost of feed. The total 70 to 80% of the total cost of poultry production goes into feed alone. And rice is a well-known staple crop, and it is economically important. It is an economically important food in the world. Rice milling waste is a byproduct of the rice milling industries. The objective of this experiment was to evaluate the impact of different levels of rice milling waste diets with phytates on growth performance and carcass characteristics of broilers, and to optimize feed formulations for improved poultry production efficiency and reduced feed costs. The study was conducted at the poultry section of the Animal Science Department here on KNUST campus for 6 weeks on 200 of 500 beds using completely randomized design. There were 5 treatments in this experiment with 4 replicates each. There were 10 beds in each replicate, making it 40 beds per treatment. Table 1.1 shows the ingredient composition of the 5 dietary treatments. Treatment 1 was the conventional feed, which is a normal feed that is already being used. And treatment 2 was 25% replacement of the maize in the conventional feed with phytates. Treatment 3 was 25% replacement of the maize without phytates. Treatment 4 was 50% replacement of the maize with phytates, and treatment 5 was 50% replacement of the maize without phytates. And this is the ingredient composition and nutrient composition of the starter diet. And table 1.2 is the ingredient and nutrient composition of the feed dietary treatment, the finisher. So we took data on the growth parameters, which is feed intake, water intake, feed to water intake ratio, body weight gain, and feed conversion ratio. And we took data on the carcass parameters too, which is live weight, bled weight, defeated weight, eviscerated weight, some primal cuts, and abdominal fats. We also measured mortality. The data was subjected to one-way ANOVA using statistics 10.0. The difference between the means were detected using Tukey's HSD test. The significant differences between means were set to a p-value of less than 0.05. The table 2 shows the approximate analysis of the rice milling waste, which we used in formulating the various diets. Table 3 shows the effect of varying level of rice milling waste and phytates on feed and water intake of broilers. From the results, we realized there was no significant difference across all the treatments for total feed intake, daily feed intake, total water intake, and feed to water intake ratio. Table 4 shows the effect of varying levels of rice milling waste and phytates on body weight gain, FCR, and mortality of broilers. From the results, we realized there was no significant difference across all treatments for initial weight and then mortality. But we realized that for treatment 4 was better than treatment 2 and 5, and similar to treatments 1 and 3 for final weight, body weight gain, and average daily gain. But treatment 4 was better than treatment 5, and similar to treatment 1, 2, and 3 for the FCR. Treatment 5, table 5. The table 5 shows the effect of the varying levels of rice milling waste and phytates on the cost of producing broilers. So for the feed cost per weight gain, realized that treatment 4 was cheaper and had a better result compared to treatment 1, 2, and 5, but was similar to treatment 3. Table 6 shows the effect of varying levels of rice milling waste and phytates on carcass characteristics of broilers. From the results, we realized there was no significant difference among the carcass characteristics of the broilers across all treatments. For table 7, we have the effect of varying levels of rice milling waste and phytates on some primal cuts of broilers. Here too, we realized there was no significant difference across all treatments. For table 8, the effect of varying levels of rice milling waste and phytates on organ characteristics and abdominal fat of broilers. Over here, we realized there was no significant difference across all treatments. So from the experiment, we can conclude that the different levels of rice milling waste did not have significant effects on the carcass characteristics on the birds. And the results suggest that the inclusion of rice milling waste is a viable option for broiler diets. Recommendation: considering the cost involved in formulating the various diets, treatment 4, which is 50% replacement of maize with rice milling waste and enzyme, proved to be the best and cost-effective and should be adopted by farmers. Thank you. considering the fiber levels of the rice milling waste, we decided to give them a uniform pre-starter diet across all treatments and started the actual experiments from yes, they help in
Do not see the benefits of your endogenous enzyme. So I think next time we could start from day one, okay? And then the concentration of the phytase.
75 grams for 50 kg of
75 grams per.
50 kg.
Okay, I'll do this calculation. Then I'll see you later. 75 grams per 50 kg. Okay, thank you.
Just a quick one. I must have missed it. What makes up the rice milling waste?
The rice husk and then grains from the rice milling process.
Oh, okay. But do you have nutrient composition or approximate composition of that?
Yes.
Okay.
Uh-huh. Yes. In your dietary formula, you indicated that you use oil.
Yes.
Which oil?
We use palm oil.
Palm oil. Use oil.
Because the rice milling waste was very dry and powdery, so we used it to make it a bit moist.
No. The energy level of that material was lower than maize, so you wanted to boost the energy level of that. But my concern is that oil is expensive. But if you look at your economics of analysis, it indicates that you are making or you are reducing, what do you call it, feed cost as you add this oil. That is where my worry lies. Because oil is expensive relative to the amount of maize that you will reduce and add the product with.
But then the rice milling waste is very cheap. 1 kg is going for about 1 cedi.
So next time you are doing an experiment like that, these are the basic informations. Give us the price per kilo of the two products, maize and then rice milling waste. Secondly, the approximate composition of both maize and then the material itself. So we can do such comparisons so that so many questions will not come. Thank you.
Right, thank you so much. I think, can you briefly tell us why you used phytase?
Phytase.
Yeah, the phytase.
Because of the high fiber content.
Are you sure about that?
Yes.
Fiber?
Yes.
No. What is, you know, phytase is an enzyme.
Yes.
What is it digesting?
Phytic acid.
But is that one fiber? Anyway, so you have to read a little bit on that, right? All the same, congratulations. Let's give it up to her. All right. Do we have a relationship between body weight and linear body measurement of waste? This one, sheep is for ruminant too. It's not even for us. Okay. So maybe we pick the last presentation from one that we missed earlier on because the presenter was not here. I'm sure this will be the last one. Okay, so please, let her assist you with the topic there so that you can. All right, so I have mentioned all the topics and then is there any
Okay, so good evening, senior managers and colleague students. My name is Tati Makija Joseph. I presence in eggshell physical and mechanical properties of local guinea fowl eggs, a link to fertility and then hatchability. Those normal dry season condition, weather condition, Ghana. Domestic poultry accounts for about, and then farmers sell fowl usually during the lean season in order to afford farm input and food materials. These birds also cultural and then social rules such as courtship and funerals, during funerals. Also, they use them for gifts. And then the demand for guinea fowl continued to rise, especially due to their nutritional value of the meat, and eggs, and also the economic importance of both. The problem, as somebody noted yesterday, the seasonal variability has an impact on the general performance of animals. And as cited yesterday, somebody noted that it has a greater impact on the gut health. And then in our case, we thought that ambient temperature, the variation in ambient temperature and relative humidity, rainfall patterns, disease and feed availability could influence eggs quality, and for that matter, that could lead to poor fertility and hatchability. The issue has been established that usually in the dry season, the reproductive performance of guinea fowls in particular are very low. The eggs that they lay are fewer, and yet when you incubate them, the hatching rate is also very poor. So we wanted to see how these seasonal variables really influence that. So the dry season is considered usually non-breeding season in the dry season, and this has been established by other researchers. But what has not been established is to see how these physical and mechanical properties interact, and for that matter, influencing or co-influence fertility and then hatchability behavior. So research objectives. The research objective was to establish physical and mechanical properties of local guinea fowl eggs. 2, to determine seasonal differences between physical and mechanical properties of local guinea fowl eggs. And 3, to determine the variations in calcium concentration of guinea fowl eggshells between the dry and those laid in the wet season. Research hypothesis. There are no distinct physical and mechanical properties that characterize local guinea fowl eggs. There are no differences in the physical and mechanical properties of local guinea fowl eggs, between the 2 seasons. And there is no variation in calcium calcium concentration between the egg cells of guinea fowl laid in the dry and those laid in the wet season. Materials and method. This was a comparative and completely randomized study. In all, 240 local guinea fowl eggs were collected from randomly selected communities within the Tamale metropolis. And the variables compared between the 2 seasons included physical characteristics. 100 eggs was used, 50 in each season to measure that. Mechanical properties, 200 eggs, 50 each season. And then egg cell calcium, 40 eggs, 20 each season. We determined the physical characteristics. We measured the weight of the egg width. We also measured the length of the egg. We measured the abdomen height. Yoke and albumin measurement. Yoke weight was taken. Yoke height was taken using micrometer screw gauge. Albumin length was taken. Shell thickness was also taken at 3 different points: the pointed end, the equator region, and then the blunt end. So at the end, we struck the average. And then the shell thickness was also measured. From the result, the following variables were also estimated. So we estimated the shape index, yoke index, albumin index by the formula given by previous authors. Hull unit was also estimated using the formula given by previous workers. Egg volume was calculated. Was also estimated, egg surface area. And then the mechanical properties. The mechanical properties usually is measured by using a machine we call universal instrument machine. However, in our case, and it works by the principle of stress distribution, like as seen in figure 1. But in our case, we couldn't get access to the machine. We made contact with Prof. Zato and co. We couldn't get it, and then we had to improvise. But we improvised based on scientific principle. So we improvised this particular figure here. You see the top one has a wooden plate, and the wooden plate, we first of all took the weight of the wooden plates, and then you see some walls under where we kept the egg on it. Then there was also another walls, which we call metal plate 2. Metal plate 2 was also weighed, and we took the weight. The weight is what we recorded on it. Now, we had earlier on did pre-testing, and we realized that you needed to put about 10 of these bricks of an average weight of about 3 kg to get the egg cracking and subsequently breaking. So because of that, we also now loaded sand, normal sand of weight of 1 gram, 2 gram, 3 grams gradually. So that when we put up to 10 and the egg doesn't break, we now continue with the smaller weight gradually until the egg cracks and breaks. So we also measured other mechanical properties, including the egg shell elasticity, which is also called the Young modulus of the egg, the static stiffness of the egg, and then the toughness of the egg. So for the egg shell static stiffness is given by the formula by Shelley and others. And then the shell elasticity is also given by the formula, this formula, which is also given by, which was derived by Bain, Solomon, and others in 1990. Shape, where the various variables have been defined. I will not bore you. So for calcium concentration measurements, first of all, the eggs were collected, and then they were labeled. Then they were weighed, and then broken. And they were weighed, they were labeled, weighed, broken, and then the shells were stored, were air dry for about at room temperature for about 12 hours, and then the shells were ground.
2 minutes.
The shells were ground, and then about 2 grams of it was taken, and then ammonium acetate solution was added. It was vortex for about 2 hours, filtered, and then the calcium readings were taken in parts per millions, and then the recordings were taken. Also, we did these readings in triplicates. Calcium content was then calculated using the formula given by AOAC as outlined. Data analysis. Data was analyzed using SPSS, and Lavenes test was applied to assess homogeneity and variance. And then a two-tailed test was used to measure the differences, the seasonal differences. So we, first of all, wanted to see the egg variables, how they behave irrespective of season. So we have the egg weight, egg length, egg width, egg shell weight, shell thickness, shape index, and then shell ratio. And these are their various ranges. These are the means and the various ranges. Now, how does season affect these physical external egg characteristics? So you see that egg weight was higher, was egg heavier in the wet season than the dry season egg. Likewise, the width and then that of thickness. We also measure the internal egg quality characteristics just to see how they behave irrespective of season. Then we measure the differences in terms of season, the impact the season could have on the internal egg quality characteristics. And then it was found that yolk index, apart from the albumin features, the albumin index, albumin proportion, and that of whole unit, which did not differ, the rest of the variables we measured were higher in the wet season laid eggs compared to lay eggs. We look at calcium. Calcium was significantly higher in the wet season lay eggs compared to the dry. What would have happened? I think I swapped this figure, the pictures, the colors. This is supposed to be for the rainy season, which was higher compared to the dry season, which is blue. Okay, so selected references and then conclude.
So, members, I think would have to pick some questions. Time fast spent. Yes, sir. Prof.
Hey, I used to.
Please, we are done with the presentation.
Thank you.
Yeah, you don't have the whole day. Are you a mechanical engineer?
No, I'm a physiologist.
Physiologist? Oh, okay. Well, when I was looking through, I thought we were in an engineering class.
So it's an objective part of the main work, trying to solve fertility and the hatchability problem of local unifowl eggs in the dry season.
Okay, so all those properties were geared towards fertility.
Yes. We want to see how they affect egg quality and how that affects fertility and hatchability of these eggs.
Is it? Okay, let me see the topic maybe. Yeah, it says seasonal variations in eggshell physical and mechanical properties of local guinea fowl eggs. So you were looking at the eggshell physical and mechanical.
Yes, Prof.
As the whole unit, how has it got to do with eggshell physical? You know whole unit?
Yes, I know how unit.
Yeah. So what has whole unit got to do with physical and mechanical properties?
You know, the whole unit is a function from the albumin height and then the shape index. So
albumin height and
albumin height. You know, because the albumin is a physical feature of the egg.
But it's not eggshell. Your topic is about eggshell, physical. If it is about egg quality in general, I don't have a problem. But if you say eggshell, physical, and mechanical, then you are eliminating any other thing which is not related to eggshell. Albumin height, all you need is albumin height and weight.
Yes.
Yeah, so every parameter you took must be related to eggshell and mechanical properties. Is that not the case? Yes. Okay, so maybe you can revise your title to reflect.
Well noted.
Yeah. Then the last one, are you expecting? Okay, so let me ask this: what is the relevance of shape index to an ordinary farmer who is a guinea fowl farmer?
So from literature, these egg properties are not independent of themselves. Usually they are correlated. Because of time factor, present correlation. So normally, individually, you may not just be able to say that if shape index is higher, it means the egg is good. But a combination of these features tells you how good the egg will behave. And of course, the nature, the shape of the egg also has correlation with the number of pores it will contain. So for example, it is found in other literature that larger eggs may normally contain larger but fewer pores compared to relatively smaller shaped eggs, who contain more pores. And then the higher the pores, the higher the gaseous exchange. And for that matter, the better the
that's okay.
For the embryonic development.
Okay. Maybe the last one, last one. This one maybe not for you, but find out whether Hall unit is also applicable to guinea fowl egg. Because Hall in 1935 used chicken eggs as what do you call it?
Measurement of egg freshness.
Yeah, so when you take, you can assume that every egg is egg. Yeah, because the measurement is where there are values related to freshness.
Okay.
Yeah, so if you use what is for chicken egg, for guinea fowl, and use the same interpretation, it may be misleading. So check if you can extrapolate that for any other egg.
Okay, okay, Prof. Thank you very much.
All right, thank you very much. But then you said you were relating these characteristics to the fertility and hatchability, is that not it?
Yes, please.
But do you have any data on your work to show the fertility and hatchability thing?
Yes, but not this particular portion of it. It's a.
So when you have such a title and these other ones are not part, you exclude it. You don't add it as if they are part.
Okay, Prof.
Okay.
All right, Abiba, let's hear from you. Okay. I know if I don't allow you, you cry.
Good evening. Good evening, everyone. I'm Abiba Mohammed, and I'm presenting on the topic proximate and mineral analysis of some insect larvae. And the insect larvae I considered were black soldier fly larvae, house fly larvae, and African palm weevil. Insects are a good source of nutrients, such as protein, fat, energy, vitamins, and minerals. Various insects at different stages of their life cycle can provide a rich source of animal protein. The demand for protein in intensive poultry production is increasing as our birds require it for their various purposes, like maintenance, production, and etc. Because of this,
insect protein can be considered as an alternative protein source to make poultry production more sustainable. Insect larvae meal contain a high amount of essential amino acids compared to conventional protein sources used in poultry feeding, like the soybean meal and the others. Researches have been done on the insect protein, primarily focusing on the use of black soldier fly and housefly larvae as protein source in poultry diets. But, however, there is a little information on the comparison of proximate composition and mineral analysis of different insect larvae. The objective of this study was to evaluate the proximate and mineral composition of insect larvae from black soldier fly, housefly, and African palm rib. The research was conducted at the Department of Animal Science, KNUST, and collection of our samples, the black soldier fly was purchased from Farm to the Land Agricultural Farming Cooperative in Accra, and our African palm rib was purchased from the Aspire Food Group at KNUST, and the housefly larvae was produced at the Department of Animal Science, KNUST. Our various insect larvae were sun-dried for a maximum of 1 week and ground with a blender for the various analysis. The proximate analysis